Human eye is a light sensing organ which helps us to see the objects around us. The resolution of human eye is calculated about 576 megapixels. The iPhone 14 Pro Max camera resolution is 48 megapixels. Now you can estimate how many times the human eye is more powerful than iPhone camera. Let us begin this chapter with structure and functions of the human eye. Parts of the human eye. This is cornea. This is iris. This is crystalline lens. This is pupil. These are ciliary muscles. This is aqueous humor and this is vitreous humor. This is retina. This is optic nerve and this is the blind spot. Now let us study each part in details. Cornea. It is a thin, transparent, spherical membrane covering the front part of the eye. Light enters our eye through this membrane. Crystalline lens. It is also called as eye lens. It is a soft and flexible jelly-like material which is made up of proteins. It is a convex lens and helps to focus images on the retina. Iris. Iris is a dark muscular diaphragm present between cornea and lens. It controls the size of the pupil. Pupil. It is a small hole through which the light passes. It regulates the amount of light entering the eye. When the light is low, it opens up completely to allow more light into the eye. When the light is bright, pupil becomes very small to reduce the light that enters the eye. The contraction and relaxation of iris muscles adjusts the size of the pupil. Ciliary muscles. They hold the lens in position and help in changing the shape of the lens. Retina. Retina is a delicate membrane which consists of numerous light-sensitive cells. These light-sensitive cells get activated when light falls on them and generate electrical signals. The light-sensitive cells of the retina are of two types. 1. Rod cells. They are responsible for vision in low light. 2. Cone cells. They are active at high light levels. They also help us in recognizing the colors. Optic nerve. It transmits the electric signals generated by the cells of retina to brain. Blind spot. It is the place at where the optic nerve is connected to the eye. Aqueous humor. The space between cornea and lens is filled by a transparent liquid called aqueous humor. It keeps the cornea moist and also it provides nutrition to the eye. Vitreous humor. The space between the eye lens and retina is filled with a liquid called vitreous humor. This vitreous humor helps the eye to keep its shape. Power of accommodation. Power of accommodation is the ability of eye lens to adjust its focal length. The eye lens is made up of a fibrous, jelly-like material. The change in the shape of the eye lens changes the curvature of the lens. The contractions and relaxations of ciliary muscles can modify the shape of the lens. To view the distant objects clearly, the ciliary muscles get relaxed and the lens becomes thin. Then the focal length gets increased and we can see the distant objects clearly. To see the closer objects clearly, the ciliary muscles contract. This increases the curvature of the eye lens. The eye lens then becomes thicker and the focal length of the eye lens decreases. This enables us to see nearby objects clearly. Far point of the eye. Maximum distance to which eye can see clearly is called far point of eye. It is infinity for a normal eye. Near point of the eye. The minimum distance at which an object can be seen clearly without any strain is called the least distance of distinct vision. The near point of normal eye of an adult is 25 centimeters. Cataract. For some people, at their old age, the crystalline lens becomes milky and cloudy. This condition is called cataract. This causes partial or complete loss of vision. This can be corrected by a cataract surgery. Why we have two eyes for vision and not just one? A human being has a horizontal field of view of about 150 degrees with one eye and about 180 degrees with two eyes. Faint objects cannot be seen properly with a single eye, so we need a pair of eyes for proper vision. What is defective vision? When a person cannot see the objects distinctly and comfortably, it is called as defective vision. It happens when the power of accommodation of eye is reduced. It leads to blurry vision which causes strain to eyes. The defective vision of human eye is mainly of three types. 1. Myopia, 2. Hypermetropia, and 3. Presbyopia. Myopia. This defect of eye is called nearsightedness. Persons with this defect can see the nearby objects clearly but cannot see the far objects clearly. We learned that the normal far point of human eye is infinite, but for a myopic person, the far point is less than the infinity. In myopic persons, the far point will be only a few meters. We know that when the image of an object is casted on the retina, then we will be able to see it clearly. Whereas in myopia, the image is casted in front of the retina. That leads to blurry vision. This can be corrected by using a concave lens. It makes the image to fall on retina, so by that the myopic person can see the far objects clearly. Reasons for myopia. There are two reasons for myopia. 1. Excessive curvature of the eye lens. 2. Elongation of eyeball. Second one, hypermetropia. This defect of eye is called far-sightedness. Persons with this defect can see the far objects clearly but cannot see the nearby objects clearly. We learned that the normal near point of human eye is 25 centimeters, but for a hypermetropic person, the near point is farther away from 25 centimeters. Hypermetropic persons keeps their reading material much beyond 25 centimeters from the eye for comfortable reading. This is because the light rays from a close-by object are focused at a point behind the retina. This can be corrected by using a convex lens. It makes the image to fall on retina, so by that the persons can see the nearby objects clearly. Reasons for hypermetropia. There are two reasons for this defect. This defect arises either because 1. The focal length of eye lens is too long, or 2. The eyeball has become too small. Third one, presbyopia. Presbyopia is the gradual loss of your eye's ability to focus on nearby objects. Presbyopic people find it difficult to see nearby objects comfortably and distinctly without corrective eyeglasses. This defect arises due to the gradual weakening of the ciliary muscles and diminishing flexibility of the eye lens. Some people suffer from both myopia and hypermetropia. In such cases, bifocal lens needed for proper vision. A common type of bifocal lenses consists of both concave and convex lenses. The upper portion consists of a concave lens. It helps in distant vision, whereas the lower part is a convex lens. It facilitates the near vision. These days, all the refractive defects are corrected with contact lenses or through surgical procedures. This is about defects of human eye. Refraction of light through prism. This is a triangular prism. It has two triangular bases and three rectangular surfaces. These surfaces are inclined to each other. The angle between its two lateral faces is called the angle of the prism. Let us pass some laser light through this prism at some angle. The light rays get deviated and emerges out from the other side. Let us draw the normal for the incident ray and the emergent ray. Now, this is the incident ray, this is deviated ray, and this is the emergent ray. Now extend the incident ray and emergent ray. They both meet at a point. The angle of these two rays at this point is called the angle of deviation. Dispersion of white light by a glass prism. If we pass white light or sunlight through a prism, it splits into 7 colors. This is called dispersion of light. The phenomenon of splitting of white light into its constituent colors when it passes through a prism is called dispersion. The light rays of different colors travel with the same speed in vacuum and in air, but in other mediums they travel with different speeds and bend through different angles, which leads to dispersion of light. When white light or sunlight is dispersed, we will get a band of 7 colors called spectrum of sunlight. They include violet, indigo, blue, green, yellow, orange, red. simply called as VIBGYOR. Isaac Newton was the first to split the sunlight using a glass prism. He placed his second identical prism in an inverted position with respect to the first one and allowed the spectrum to pass through it. He observed that a beam of white light is emerged from the other side of the second prism. Rainbow. Rainbow is a natural spectrum formed by raindrops. It always forms opposite to the sunlight. Here, the water droplets act as small prisms. When sunlight hits the raindrops, they refract and disperse the incident sunlight, then reflect it internally and finally refract it again when it comes out of the raindrop. Atmospheric refraction. Atmospheric refraction is the bending of light as it passes through the Earth's atmosphere, causing objects near the horizon to appear slightly higher than they actually are. Effects of atmospheric refraction. Apparent position of the stars. The apparent position of stars refers to their observed location in the night sky. This is the original position of the star. But due to atmospheric refraction, it appears to be at another position, which is called as apparent position. The density of the air near the Earth is more compared to the density of the atmosphere towards this space. This makes the refractive index of the atmosphere gradually increases top to bottom. Due to this changing refractive index, starlight bends towards the normal. Because of this, we see the star at slightly different position from its actual position. The star appears slightly higher than its actual position when viewed near the horizon. Twinkling of stars. The air in the atmosphere does not have the uniform temperature and density. Different regions of atmosphere will have different refractive index due to differences in their temperatures. The path of rays of light coming from the star goes on varying slightly. The apparent position of the star fluctuates and the amount of starlight entering the eye flickers. The stars sometimes appear brighter and at some other time fainter, which is the twinkling effect. Then why don't planets twinkle? Planets do not twinkle like stars because they are much closer to the Earth and appear as small, extended disks rather than a point source of light. The light coming from them consisting of multiple points across their surface. The combined effect of these multiple points of light helps to average out the atmospheric turbulence, resulting in a steadier and less twinkling appearance. Advanced sunrise and delayed sunset. When sun rises above the horizon, it is called as sunrise, and the sun downs below the horizon, it is called sunset. The horizon is the line that separates the Earth from the sky. When the sunlight enters the atmosphere, due to atmospheric refraction, it bends and the sun becomes visible to us before actually crossing the horizon. Then we will be able to see the sun here, but this is not the actual position of the sun. It is the apparent position of the sun. So, due to atmospheric refraction, the sun is visible to us about 2 minutes before the actual sunrise and about 2 minutes after the actual sunset. Scattering of light. When a particle comes in the path of a light ray, the light gets reflected and scattered in all directions. So, the reflection of light from an object in all directions is called scattering of light. Scattering is responsible for the blue color of the sky and the reddening of the sun. Tyndall effect. The Earth's atmosphere is a transparent medium in which particles like dust, smoke, and tiny water droplets are freely suspended. When a beam of light passes through this medium, it illuminates these suspended particles and makes them visible to us. This phenomenon was first observed by John Tyndall, hence it is named as Tyndall effect. Color of the sky. Sunlight is composed of spectrum of colors with different wavelengths. These colors range from red with longer wavelengths to violet with short wavelengths. When sunlight enters the Earth's atmosphere, it encounters tiny particles and molecules. Blue and violet light rays have shorter wavelengths and are scattered more by these small particles and molecules than longer wavelengths like red and yellow. As a result, when sunlight enters the atmosphere, the blue and violet wavelengths are scattered in all directions by these particles, causing the sky to appear predominantly blue during the daytime. If Earth has no atmosphere, then there would not have been any scattering, then the sky would have looked dark. The sky appears dark to the passengers who are flying at very high altitudes. Why stop signal and danger signal lights are red? Danger signal lights are red in color because red is least scattered light by fog or smoke particles. Therefore, it can be seen in the same color even at longer distances. That's why red light is preferred for danger light. Color of sun at sunrise and sunset. During sunrise and sunset, light from the sun passes through a thick layer of atmosphere and large distance before reaching our eyes. When the light enters the atmosphere, there most of the blue light of shorter wavelength is scattered away by the particles of the atmosphere, and the light with longer wavelengths like red reaches our eyes. That's why the sun appears red during sunrise and sunset. This is all about the human eye and the colorful world. Thanks for watching.